Assalamu alaikum rahmatullahi wa barakatuh. Myself Muhammad Abdullah, and today I am going to teach you my first lecture on microcontroller and embedded system. In short form, you can say it's MES. We are going to follow second edition of AVR microcontroller and embedded system using assembly and C language. In lab, we will also use Arduino Mega 2560 and some others, ESP32, and we will also do a project on SD card with line folder. So moving ahead, my society Megafuse, we have prepared slides under this society. Moving toward our lecture number one, the topics are parts of computer which contains input output devices, memory and CPU. Input output devices means any device from which we will give input signal to a computer, and our device will process, or CPU or computer will process and give a signal to the output or an output signal to the output. These input devices can be keyboard, mouse, sensor, or output devices can be LCD, printer, hands of robot, and many other things we can say. Moving toward connecting memory to CPU, then we will study connecting input output to CPU, and then we will study how computer works, and then we will study the microcontroller and how to choose a microcontroller, because it's too much important to know how to control and how to which microcontroller is for you, because we can't use every microcontroller in every project. It will make your project bigger or maybe worse than, because even speed is matter in while choosing a microcontroller. Anyway, moving toward part of computer, part memory. So anything that can store or retain or recall information, like hard disk, our brain, or even if we write a piece, something on paper, it also a piece of memory. The characteristics of memory are capacity. Obviously, there's a limited space. It's not like brain. It's human-made things. Only Allah can made unlimited space like our brain have. Even scientist doesn't know even how much properly space in our brain have. It's currently unlimited. So moving toward our topic, it can be 128 KB, 256 GB, 1000 TB, terabyte, and many others. It is organized location. For example, you can say in this picture on the right 128 locations, and each location have 4 bits, means 0000. It's a 4-bit number. Anyway, moving toward the access time. Access time means how much time it will take to get data from memory. For example, nowadays we have 3.2 speed USBs and people prefer them. And moving toward another example, so SSD are more faster than STD. STD are older and SSD are lighter, faster, more advanced of today. Now moving toward, it can be semiconductor or non-semiconductor, because non-semiconductor was the old generation, because it used they are floppy disk without an IC, without any conductor. That's a non-semiconductor. That's not even a conductor. And nowadays we are using semiconductor in IC based RAMs. Even our normal PCBs of projects are made of transistors, normal amplifier ICs, all of them are made of silicon or gallium. Both of these are semiconductor. Now moving toward the type of memory, there are two basic type of memories, ROM and RAM. The types of ROMs are mass RAM, which can only be programmable by the IC manufacturer, while another type is PROM, programmable ROM. This is only one time programmable. You can it means there is no code inside it. When you will buy it, you have to inside code inside it, but don't forget only one time, because but sometimes it will be used inside your PCB by a company, and it already programmed, so you can't program it again. EPROM, the UV ultraviolet radiations are needed to erase it. You can also place it in front of sunlight, but it takes 20 minutes to reset itself. Yeah, it's a huge time. You don't have enough time nowadays. But it was the past and it is the present where everything is measured in nanosecond. Everything is possible in nanosecond. Even we are moving more reduce reduction of time in our things. So this is too much. 20 minutes, what do you mean by 20 minutes? I can't wait for 20 minutes. In fact, our Arduino Uno is slow. It was slower than ever because it take around seconds to insert a code inside it. Sometimes it give error and wastage of time. Anyway, move toward another type, EEPROM. Electrically erase instantly. Each byte can be erased separately in this technology. Now moving toward the flash ROM. Flash ROM is the very advanced technology in our current generation. So in flash ROM, entire device is raised only at once. You don't have to wait a lot of times like in Arduino, like in other older devices, like in other ROMs. Anyway, moving toward the type of RAM. So there are three type of RAM: SRAM, DRAM, and NVRAM. SRAM means static, D dynamic, and NV non-volatile. These are the flip-flop. SRAMs are basically made of flip-flop. Flip-flop are, they need to refresh again and again because there are more around four gates and one selection. So there are a lot of gate delays due to which it need lot of refresh, make it expensive and higher power consumption because of there are four gates and then the selection pins. This is just a minimum structure, but there are unlimited structures. I am just giving you a example of one flip-flop. You have to attach number of flip-flops to get the proper output and made a SRAM. Now moving toward the dynamic RAM. Dynamic RAM actually cheaper because it uses capacitors, which increase the capacity. Actually, capacitor is while the capacitor discharges, it means zero, and the capacitor is full, it means one. So it replaces with zero one in this way. Even our older CPUs were made using capacitor, which were, and you all know, CPU is one of the most fastest thing in your whole computer, even with your RAM or ROM. So moving toward the next thing, non-volatile RAM. It is made of SRAM, battery, and control circuitry, which make it faster because SRAMs and battery made each other powerful, and then we got a control circuitry. But even after it's an older technology. Nowadays, we have far better technology. But it have infinite programming and erasing cycle, non-volatile, but it is expensive. We can't use it. It was expensive. Now moving toward the CPU. What is CPU? It is the central processing unit. Just like our brain is connected with our uh, foot, feet, shoulders, and every part of our body, because everything we sense is because of our brain. So just like our brain, in computer or any device, CPU is the main thing. Even our microprocessor, everything is attached to the CPU. The internal parts of CPU, the parts which belong under the CPU or from the CPU are program counter, arithmetical logic unit, registers, and instructor decoder. Now moving toward the topic connecting memory to CPU. So this is CPU, and we have connected memory. This is called as memory, normal memory, where we sit and ground the normal to on or anything. And then this is a data transfer, and this is analog data transfer. These are digital pins, and this is writable, erasable, and this is only NCS. This is algebra. So reading from memory. Whenever something we are going to read from memory, it will be transferred from this bus digital pins, and if we want to transfer it back, it will transfer using analog side. So this address valid. If this address is valid, which is sent by CPU, it will send back the memory will send back data from that location using this bus. And at that time, we are reading something, not writing something. So writing is one, and after it when we are writing something inside the memory, we will send the signal again from this bus, and the signal will be sent from this signal not that some memory sent from this was a signal that where it will be saved, but the memory for the thing we want to save will be sent from this bus. And as we are not reading now, so this is 0, you can see data hold and then transfer. So connecting input outputs and memory to CPU. So this is a CPU and we have connected inputs. This is memory where data is saved, and we can say drivers are also saved of input devices. So you can think that all input devices like CPU, like oh, sorry, not CPU. CPU is not an input device. Like mouse, keypad, touchpad, camera, mic, microphone, and many other input devices. So our memory, basic thing is the memory data bus. This data bus will send signal, and this address will find that signal, the address using that signal and send it back. And here's the thing, input output, which is helping to manage all input devices. We must have, you can see here, we must need a logic between 0 to 15, for example, the devices before it, to detect which input device is sending a signal, because we must know which input device to ignore and which to send signal, just to send which is sending signal. So how to make this logic? Write the address range in binary, means write whole range in binary. For example, we are starting from 0 to 15. This is the 0 in binary and 15 in binary. Then name them. Then separate the fixed part of the address, which is this one. You can see, where's my cursor? Yes, this one. So now design your logic whose output activates when the fixed address is given to it. This is only possible when in NAND gate, when you will add NOT gates at back and NOT gates at the end, which will make it a NAND gate. You can see NAND gate and NOT gates behind. So NAND, NOT cancel each other. It will simply act as an AND gate, and it will only respond when the same address is here. For example, let's suppose 0001. So for 0001, there is first input device connected will respond to the CPU. So moving toward, these were the things we have learned in DLD, or you have also learned in DLD. So this is the conversion of decimal, time made tech, and decimal to binary. We have to divide one by one, one by one. Dividers are here. You can say this process was similar to LCM, taking LCM and writing reminders on the side, which was a new thing, and then collecting the reminders from bottom to upper and writing it here in the form of binary. In the same way you have to do for others to binary. Now moving toward hexadecimal to binary. So we have to write 2 to power 0, 2 power 0, 2 power 1, that's 0, 1, 0, 1, that's all that. So first to convert in this and this. Now moving toward, this is hex to binary 29. You have to first convert 29 and see B from here. B is 1011 and right here. You can see B is 1011 and others are also taken from there. 9 1001 and 2 0010. Now convert decimal to hexadecimal. For it you can see the similar way here, and in this case convert binary to decimal. So you can start from here, 0 1 2 3 4, 2 power 0, 2 power 1, and then add each other, and then you have a final answer. To convert this you can use the inverse technique, binary to hexa. mean 1001 9. Here written 90101 means 501015, right? Three of them and right here. Now moving toward addition. This was the simple addition we have learned in TLT, and this was the binary addition. We have also learned it as a half adder circuit, and this is the complement. You can also say it's a minus of this number. Now moving toward, these are AS special characters, and these are also control characters which are used in behind the logic of our keyboard. So we are going to discuss another example of address decoder which we have used at how to control the number of inputs with the CPU, how to manage them. So write the address in binary as we have discussed earlier. Write the location, separate the fixed part of address which is this one 0000, and 11 is also, sorry, 11 is also similar because it's not changing. Then design the logic using NAND gates. We have designed the logic using NAND gates like 00 and 11. If 0000, then we will write here 0000 and this. So moving toward, this is similar. We have learned it here. How computer works. So this is another topic, how computer works. It's very important to learn how computer works. For example, this is memory and these are the input devices. Now, first of all, our program counter have an input of 0. So it will go on, we will transfer it using a address bus. And you can see addresses 31 as 31 will be written here. And then 1 will come here. So 31 is missing here right now. Yeah, this is 31. And then for first signal, A is decided as 17 and 17 will be sent back. This is the information that is stored in this location. There 0 is sent, and this 31 this is actually, you can say it's hexadecimal terms or another language. So continue that statements BA. Now, if we consent 1, it will send back A to us, which will go here. You can see 9, and we are sending 1, and 1 is sending C4H back, which will be written here. And again 9 came, again 6 cone, program counter is updating. We are writing 5 plus 9 happened, that's actually addition. No, you hopefully you understood what I was saying there. Now moving toward how instruction decoder works. So actually, this is memory. Memory is always in binary or assembly. This is a binary language written here, and this is 0, 1, 2, 3, 4, which we can understand as an address, and this is what we are understanding. And okay, so first of all, opcode. Opcode is a memory binary code which is going to be used as operation. For example, 000 means send X to A. So this is the instruction which is you're going to follow, and it means 000 means, and this X means that its first number 00000001. And then if the operation code is 001, it will remain the same, but there's something little change which will make 10. Then 010 means minus register X, and then continue up to so on. Moving toward the next slide, Neumann and Harvard architecture. In Harvard architecture, both code memory and data memory both are in parallel with CPU, but not in parallel with each other. Why? In non now in one Neumann Both data memory and code memory are in parallel to each other but in series with the CPU. Moving toward the next slide, difference between microprocessor and microcontroller. That's a simple thing because everything comes inside a microcontroller, whether it's RAM, ROM, timer, input output, speed, oscillator, or while in microprocessor everything is joined with it. Like it's not inside it, it's just joined with it. Like input devices are joined, so it is joined as a memory devices like RAM, ROM, timer, serial component port, input output ports, all are joined with microprocessor. So and using the help of buses, 8-bit microcontroller. So we are going to discuss 8-bit microcontrollers. We have different type of chips in it: Atmel, Microchip, Intel. These are some of the popular companies. While if we want to discuss about 40-pin packages, so program ROM, data RAM, EEPROM, which was the older one, timers, input output pins are special tools in area. Now moving toward the embedded system. Embedded system is controlled by its own internal microprocessor. Embedded means which is already embedded or pasted inside the system or inside the controller holder. It's not like external component, it's an inside the component, internal component. And so and piece that is connected to different things because we have already discussed. But it will not like that ports, RAM, ROM. It already inside a microprocessor. It's not a microcontroller, it's a microprocessor. Now moving toward the embedded products, our PC, notebook, laptop, these are our daily use things. Banking, even banking tools, VDRs, cameras, remote control, security system, toys, firewalls, all are embedded system. Now, one of the most important things of today lecture. You can say it's one of the most important topic of this lecture. Choosing a right microcontroller. So it's too much important to choose a right microcontroller. Whether it's speed, packaging, power consumption, RAM, ROM, timer, input output, cost, compiling, simulating, debugging, or availability in the market. Availability in the market is one of the biggest thing because some of the countries in Asia have faced a lot of issues other than China, and in the same way African also face a lot of issues because all type of ICs, all type of microprocessor, a lot of sensors are rarely available. They are just basic things which are available for student projects. Other than it, companies own their own from international market, but they are not supplying anywhere. So that's harder for their students. So moving toward why speed is important, and because speed is important because you have to take a lot of processing. For example, in you can take a simplest example of line follower robot. It will move with a speed. It is depending on a speed. You can't say that. With a speed of 1 megahertz you can control a line follower too easily. It will have lot of delays. In even Arduino Uno, which have almost around fourth slowest speed in microcontrollers, have 16 megahertz processor. So 1 megahertz processor is obviously slowest than ever. Now it depends on you need a tip or quad flat package or SMD package or any other package. It depends on you. Like SMD, Arduino Uno, where the SMD microprocessor is used, while in DIP, DIP microprocessor is used, which is not which is DIP means to embed something using holes, not using directly solder on the PCB. It will for it you will do holes and then that means dip. Power consumption. So obviously devices have more power consumption than the SMD or QFP ones. The amount of RAM or ROM obviously matter. It also matters on speed. You can't do a lot of things with lower RAM. You can play a lot of games in your PC even with faster RAM, with the highest RAM. Like uh, nowadays, 8 GB RAM is also becoming older and older and can't be good for even normal use of students. The number of timers and input output pins obviously important because if we talk about smaller chips, they have little input plus they have their input pins to around 4 to 5, which are two minimum for controlling anything. For especially at that time, PMW becomes minimum. So moving toward next thing, this is AVR microcontroller family Mega 32. This is inside process. We don't have and sources for it, but we have already read that this is CPU. This is RAM, EEPROM, timers, other peripheral, interrupter unit, ports, input output ports, oscillator, program, flash ROM. This is known as ROM. This is known as RAM. This is another ROM. This ROM is for temporary storage ROM. Now moving to part the block diagram. This is the block diagram. There's no need to understand it. Just see it and ignore it. Now moving toward the AVR microcontroller family. 32 bits. 32 bit. They are almost most efficient 32-bit MCU. Program memory is 16K to 512 kilobytes, while packaging means that it have 48 to 144 pins. Frequency is 6 to 6 megahertz. That's the best one, and performance is 1.5 meg per hertz where it's lag. X Mega AVR. So this is Atmel AVR X Mega. It's not too much in performance. Upper one was better than this one. Now Mega AVR. They are powerful microcontroller with more than 120 instructions and lot of different peripheral compatibilities which can be used in different design. It is one of the fastest one, but still it's not that level which its builder want to achieve. Now moving to a tiny AVR, it's smaller package and faster than ever. Now we are going to discuss some at Mega 8, at Mega 16, at Mega 32, at Mega 64, at Mega 128, and these are tiny at tiny 13, at 2, at tiny 84. These things have meaning. Like Mega means which IC is gonna use, 8 means kilobytes. You can see here 8 mean Atmel IC, and this is the company name. Oh my god, this mega means X mega 32-bit, tiny. If they're 64 written, 64 is basically made for our computers, our laptops. It's not made for our microcontrollers because it's too much heavier. But it can be used in future in Raspberry Pi or STM coming and replacing all of them. And this is flash in memory. This is the modern technology. So bye bye guys, have best wishes for your exam. Hopefully you will listen my lecture in your exams and remember me in your prayers because I know I have given you one of the best lecture in the world. So bye bye tata guys. We'll see you in another lecture with another other stupid kahaniya. Bye bye tata.